Okay, good. Richard?
Well, good morning. It's my great pleasure this morning to introduce my friend and colleague, Kent Sugden. Kent is chairman of the chemistry department now. He's a native Montanan, grew up somewhere in eastern Montana. I don't really know where. He has, I believe, 3 degrees from Montana State University, 2 bachelors and 1 PhD, and he's basically a bioinorganic analytical chemist, and most of his research work has involved the toxicity of various ions of chromium, 3, 5, and 6, I think. Uh, and that's what he has done for research. Uh, After going to getting his PhD from MSU, he went to Dartmouth College and spent quite a number of years there as a postdoc and finally as a research professor. And then he came to the University of Montana in 1999, a long time ago, which he teaches and does research. And for the last 3 years, I think it's 3, he's been chair of the department during some very difficult times, actually. And I've kind of watched from the sidelines, but my belief is that Kent has done a superb job of being chairman. And I think the most remarkable thing to me is that he's done it with great grace, which is hard to do in these days, to be graceful. So in any case, his lecture today is on trials and tribulations of remote learning. Thank you for coming, Kent.
Thanks, Dick. Thanks for that that introduction. Let me see if I can share my screen here. And throughout this, if you can't hear me or something, let me know. If you have a question, just speak up. I'm used to being interrupted while I'm lecturing, and I also am used to having students sleep on me while I'm lecturing, so don't worry about that. Dick asked me to talk about what's been going on in the department for the last, what has it been now, 6, 7 months, trying to adjust to this new remote learning with this COVID environment, and it's been a challenge. It's been a challenge for us. It's been a challenge for the whole community. If you have kids in the MCPS system, you know how challenging that's been as well. But I'm going to stick mainly to what we've been doing in chemistry and biochemistry because, we have some unique challenges in that chemistry is a hands-on science. So you need to actually practice chemistry to be a chemist, and that's hard to do in a remote environment. Now, I'll show you what we've been doing here in the different semesters since we got going. First of all, I want to throw in some definitions here because we often hear about the concept of remote learning and how it's being used, but we're using this in a kind of a haphazard fashion. What they call the modality of the content distribution can be broken down into what we used to do, which is all face-to-face, students walk into the lecture hall, faculty member stands up and drones on for an hour and then they're done. So it's the normal way to do things, but obviously is not something that we've been able to continue, at least not to any degree. We have what we call remote learning, and remote is kind of like what we're doing now, where there's this synchronous lecture where they're supposed to show up at the normal time of the lecture and watch on a web-based cam, just like you guys are doing right now. And that is the true definition of remote, but we're using it to also encompass things like this hybrid or blended model. One of these is called a high flex, and this is really what we're being pushed to do this semester. That was not true early on. And basically it's this blending of face-to-face and online, where some students show up and some students do it remotely. It's synchronous, but it's also recorded. And that's, you know, versus the normal, what you would consider online that U of M does. So when I'm talking about remote, I'm really talking about this mixed between remote and the hybrid blended here. And I'll be specific as we go on a little more. So I wanted to put this in context. And so I've got this COVID timeline. And if you remember, let me just start it here. And then I'm going to be stopping this as we go along. So January 24th, actually it was January 23rd, I made the prediction that we would be not coming back from spring break, at least not face-to-face. And I was not terribly serious, but it turned out to be dead on. But that's when, you know, late January was when the first cases started showing up in the United States, Washington and Illinois. But not much happened for a little while. And as we go through this timeline, however, I want you to watch the change in California, and let's see, Washington should be showing up here pretty quick. And the number of cases over time, not too much really. You can see that suddenly, late February, early March, these cases just really start blowing up. And you should remember what the student body is at the University of Montana. It's 35% out of state. And most of those are coming from Washington and California, at least a large percentage of them. So we went from very few early on in this environment to suddenly getting this, you know, hyperbolic, you know, curve of cases in Washington and California. So this is early March. And what's interesting, if you look at the death rate, it goes up rather dramatically. It comes back down, but let's move this on just a little bit. I'm not going to show you the whole thing. Don't worry about that. But as we move through March, the number of cases, this get recalibrated. So, but once again, it's showing you this dramatic change in the number of cases in the Washington and California area. This, of course, is when New York started blowing up as well. Oops, let me go a little bit further. But March 9th, note that there's still no COVID cases in Montana at this time, none even in the area, with the exception of mainly Seattle. But the Commissioner of Higher Education and the Board of Regents sent out a memo on March 9th to all of the faculty and the chairs that even though there are no positive cases in Montana, if things get worse, we need to consider going remote. What's interesting is how quickly we went from this on March 9th to March 12th, where suddenly we go from no COVID cases to on March 12th, a COVID case popping up in Montana, Washington's still blowing up, California's still up there. And March 12th is when the next edict came down from the Commissioner of Higher Education, telling us to transition to remote teaching. Now, March 12th was the Thursday before spring break. So basically that gave the faculty one day, Friday, to tell their students, and this is prior to spring break. Half the students had already left for spring break by the Friday before spring break. So most of your students weren't there. And then that left us 1 week, basically, to transition our teaching from a face-to-face to a remote type of modality. You move forward, we keep going up, but that's not necessary. Spring break this is the Monday through Friday, so March 16th to 20th. So here's your academic COVID timeline. So spring semester 2020, right after the March 14th memo, it was major league panic on campus. I've really never seen anything like it. Technological meltdowns everywhere. A lot of faculty didn't even have a webcam. They could not do Zoom if they wanted to. They needed microphones, writing tablets if you want to do equations or structures in chemistry. And I would say the one thing there was a great response from the college and the provost's office to get us that equipment on a timely manner. And there was, well, about as much support as you could get in terms of the technology. We were lucky. We had a fairly newly hired administrative assistant who is technologically savvy and helped us out, all of us old faculty members who were technologically challenged, we'll say. But on March 23rd, we had transitioned to complete remote or online components of learning for chemistry. It was quite an undertaking and quite impressive in some ways. I wouldn't say it worked as well as we'd have liked. There were a lot of growing pains from the technology. If you just look at, here's the growth of Zoom, and it's just exponential growth from December 29 to April with the number of users. Here's some of the other online learning platforms. Zoom, of course, there's the January 1, 2020 marker here. Zoom is what U of M uses. Google Classroom and Google Hangout are two of those things that the MCPS system uses. They're for Chromebooks mainly. So this led to a lot of problem with bandwidth. Zoom crashed constantly on us. Some students at the university level even had low accessibility to that technology, either from a computer that could do Zoom, or they had no Wi-Fi at home, or poor Wi-Fi signals even in for those that stayed in the dorm room. So there was a big learning curve, we'll say, for moving into this new remote learning platform. So this conversion was really arduous, and it took the faculty, I don't know what everyone else put in, but I put in probably 80 hours over spring break just learning how to generate, recorded lectures with Zoom and with PowerPoint, and being able to post on YouTube. And it's the technology was something we just never really used. And like I said, it took a huge investment. The most common method that was used during spring was this sort of hybrid blended method, in the sense that there was synchronous lectures and online proctored assessment. My own class, I did asynchronous lectures, made YouTube videos, sent the URLs, and then had discussion sessions that were synchronous, along with synchronous help sessions. So, everyone did it sort of their own way. There was no standard at this point in time. One of the problems, of course, is when you do remote, the best you can do is what's called online proctoring. And it's doing basically what you would be doing here. You're staring at me and the screen, and you really can't see what's going on. The problem with this is massive cheating. You would like to think that that's not true, but it is. And in fact, even those students who would never consider cheating realized that they were at a massive disadvantage if they didn't. So it's making the honest man dishonest in a sense. One of my faculty was sending me data at the time, and they saw a 15 to 20% increase in the average test score. Certainly well outside anything you would expect statistically. In fact, I would have expected it lower. So, I mean, even with people staring at them you only see what they're doing, you know, and it's hard to see what's going on in the rest of the room. Not optimal. And it's particularly not optimal in my eyes, in that these are the people who are going to go on, oftentimes, for my class anyways, was, you know, these are going to be your, you know, your MDs, your physician assistants, your pharmacists. Yeah, these are people I want to have, you know the content and know it well. So while the lecture course was, you know, reasonably readily converted, the problem with us was our laboratory courses. How do you take a laboratory-based science like chemistry and move it to remote technology? Remember, when we quit at spring break, when we stopped the normal face-to-face lectures and went all remote, we still had 5 weeks of the semester yet to finish. If this had been 2 or 3, we probably would have just written off the last few weeks. But at 5 weeks, we really couldn't do that. So we had 2 options. And one is that we dry labbed it. We had a faculty member or a TA film the lab being carried out, collecting the data, and then you'd send all the students the data, tell them to write it up, send in the lab report, and then it would be graded. This generally had a poor outcome. It did not, it was poor pedagogy. It got them through, but it was not optimal. We also had designed some labs that they could do at home. We didn't have much time for this. We had a week's notice. The lab design takes a long, you know, weeks and weeks to do this well. But, and you also have to rely on things that they can get from the supermarket. We had mixed results on this depending on the motivation, but I want to show you some stuff that came out of this part, these labs done at home. Because depending on the motivation, some of them really took it to heart and I think really enjoyed what they were doing. So here's a at-home pH lab that was designed by Dr. Brooke Martin for her 120 series course. This is an introductory chemistry course for like soft science majors and pre-nursing, forestry. And what you do is you take a red cabbage and you extract a dye out of it. You have basically a indicator, and it changes color at different pH, meaning it changes color depending on how acidic it is or basic it is. And they could do this at home with various household items. Of course, even these household items, you always want to think about safety. So we tried to make sure they wore their safety glasses during this experiment, and taking it to a whole nother level. So what we found was that some people who took this, you know, enjoyed this. They did it with their kids, and this should also be a reminder about what a lot of our students are here at University of Montana. They are non-traditional students. They are people with kids. And something we hadn't even thought about was, yeah, they're going to do this with their kid. And you can see here's the different household items they chose. Then they added the indicator from the cabbage and got this change in color that they can then match up on the chart to know what pH it is. Okay, so coffee's not a great one because it's too dark, but everything else was nice in that it matched up. One thing you should see that would maybe scare you is, even though they're household items, here's bleach and there's Windex, you know, that's, you know, you mix those two things and you generate chloramine gas, which can kill you. So those are the scary parts of doing chemistry at home. Here's another one. They sent this, very nice thing. One of the things they chose was vodka. Kind of a waste of vodka if you ask me, but you can see pre and then post addition of your dye indicator. And then here's something I had with it. This tells you some of them really enjoyed this, and the Markham twins made a TikTok video. So, so I have to admit, when I was shown this video, I'd never heard of TikTok, but apparently this is a big thing, and we got several videos of the students doing this. So it wasn't all, what I'm saying is it wasn't all bad going to this remote. Some of them took it very seriously and enjoyed themselves doing it. Here's just a few of the student comments, had fun doing this with my kid. I like this one. We had a good time for about 5 minutes. We had a good time. And for about 5 minutes, I had a teenager think I was smart and cool. So anyways, that's how we finished up our spring semester. However, we still had, we don't stop there. We had summer semester, and things were still in kind of panic mode. And what we put in we petitioned to be allowed to hold face-to-face labs. One thing that was kind of obvious is that you can put together a few labs for them to do at home, or film some labs and give them data for a couple of these, but you can't do it for a full semester of laboratory courses. So we petitioned to be allowed to do this. And it turns out, to my knowledge, we were certainly the only chemistry department in the state of Montana, but possibly even in the Northwest, that held face-to-face labs. It was not without a lot of problems. The president had stated and sent out emails to all the students saying all summer courses would be remote. So we had to go back and say, no, the lab portions for our courses have to be done face-to-face. So we got lots of angry emails and calls from parents. I had the summer coordinators and the dean's office yelling at me, even though we were given the okay to do it. That's why I have this clueless in academe and left hand and right hand not knowing what they were doing. People were still in panic mode. The nice thing about this is we initiated the COVID protocols in the lab that were used and are currently being used all throughout the campus, because we were the first to have face-to-face courses back. And here's just an example. Not only, as you can see, not only do they have to wear their safety lab glasses, they had masks, which at the time you couldn't get masks. So we had a local, seamstress make these masks for us. Note also the distance between these two. Normally a bench like this in the chemistry labs would have probably 4 students at this bench. And so we had to social distance them to have only 2 at a bench to keep that 6-foot distancing. This, of course, took significantly more manpower. The great thing is we had no COVID cases, no transmission during the summer. So we pulled it off, is what it means. It was a little touch and go for a while. The students actually turned out they enjoyed it. We would have a no-touch, thermometer that they would have to, shoot themselves with every day coming into lab and make sure they didn't have a fever. They actually enjoyed the summer course doing it this way. And we got some students back on track for their degrees. So that, of course, leaves us to where we are now. So as I said, the president came in and said, we want to do face-to-face as much as possible. But we want to do that being with the 6-foot social distancing. We want to do that while having a remote component for those students who may be susceptible to COVID, more susceptible to COVID. And so that posed a lot of problems. One of those is that the lecture halls could only then hold 20% of their normal capacity. So we have, I don't know, 2, maybe 3 lecture halls on campus that can hold 500 students. So if you have a a class of 100, you basically can't hold it anywhere on campus. So it's been really problematic just getting the capacity. So that's when we went to the high flex model. And some people do this differently than others. Some of them split their classes into whatever chunks it was necessary to fit into the classroom size. And then they said, okay, this bunch A through L comes on Monday, L through X comes on Wednesday, and then Friday's all remote. It's not really optimal, but it does give some students an example to do, a way to do face-to-face, excuse me. My own class, I was kind of lucky. I have 2 classes, but one main one that has 40 students. I was in a lecture hall that could only hold 23. And I just asked which students would prefer to be all remote versus face-to-face, and it was about half. So I was allowed to do face-to-face with whatever students wanted to show up. And it worked out well early. Right about now, I'm getting lucky to get 4 or 5 showing up because they know they can just go on their computer and do it remotely. One of the real problems with the whole remote option. You see, the lecturers are forced to wear face masks and record and post every lecture. Here's just an example. This is me, and I won't play it very long, but this is exactly how my lectures end up being recorded and posted, masked up in my classroom, doing a PowerPoint presentation. I'm not going to bore you with that, but there's some real problems with that. It works well enough. So where does that leave us for the rest of the semester? If you've been watching the Missoulian or any other sites, you know that we are increasing our COVID case numbers. If we look at COVID cases by age group, we see that the 10 to 19 and the 20 to 29 age group, which is the University of Montana, is increasing dramatically. Can we continue doing any face-to-face, or will we need to move back to remote? Well, so far they've resisted that. I agree with that personally. But remember, I mean, you've got this many cumulative cases, this number of average close contacts. These students are all going into quarantine, which leads to real administrative problems. So, like I said, the optimal outcome is to stay the course as we're doing it now. We get increasing number of students with COVID. And I put this in parentheses because the legal counsel has been sending us constant reminders that we cannot ask the students for proof of COVID, being pro-COVID positive, or proof of even quarantine from a close contact. Something that I have pushed back on dramatically with the provost, because previously missing a class or missing a test for health-related reasons, it was necessary to have a doctor's note. And so to me, this is no different. And for some reason, they are not really allowing that. So a student can email you and say, I'm a close contact. How do I take my tests remotely? And for me, I say you don't. I give them a 1-drop test for a no-fault drop test, and anything more than that, they'll have to come back and make it up. But I only have, like I said, in my main class, 40 students, 12 in my other one. So the classes with 400, 300, 400 students have, as you can imagine, hundreds of these kind of COVID excuses coming up. Some are obviously true, because with that 270 cases, 4.2 close contacts, that's over 1,000 students in quarantine. Now, it hasn't been all at once, so this is not an all at once, and some of them are released early. So what are we going to do? That's a real good question. we've been floating the idea of having short winter session lab makeups, test makeups. That takes resources that right now are pretty scarce at the University of Montana. What are the administrators saying about remote learning? Well, I say this to the administrators because anyone who thinks that it's been very successful or largely successful, is not actually on the front line teaching students. I'd say most everything should be in the orange here. There's some successes and some failures, but you can see this is just a poll, what's out. Interestingly enough, there's a lot more data out there. Some of it's not as easy to find, but generally the remote thing is a stopgap. It's not going to take us very far, in my opinion. And what can we actually look forward to? There are a lot of negative long-term consequences. The students that are going to be coming into the university are not going to be prepared. CDC has a lot of discussion on this. We have a big discussion on reopening schools, which I'm all for. I have a 13-year-old daughter in 8th grade, and the MCPS system is not working. That's all I can say about that without getting in trouble. They've suggested that lifetime losses in income will be 3 to 5% because of COVID from students coming up. The number of students leaving high school early has increased dramatically. And the long-term consequences of this are going to be significant in academia. And that's what we have to look for. That's what we have to plan for. So that's what we've been doing here at the chemistry department, largely similar across most of campus. Thanks for your time. Any questions?